The difference between uncertainty and tolerance. Use your own words to give examples. Okay, so uncertainty, you can say something like this. It is the margin of error and it's determined by what? By the device, measuring device. Okay? A tolerance it is the variation allowed. It is the variation allowed for an item to still be useful, or still be used for its intended purpose, to still be used for its intended purpose. For its intended purpose, you can say tolerance is the range between the minimum and the maximum allowed measurements. You can say that it is determined by the industry. Raven, did you have your hand up? Oh, you were just scratching. Something like that, okay? So tolerance is what's allowed in a certain sector, certain industry, okay? So that the part can still be used for its intended purpose. Uncertainty is simply how much a measurement could be off by given its precision, okay? You could say, if you wanted to be more specific, uncertainty is equal to half of the precision, or precision divided by 2. Do you remember I told you precision, uncertainty, to go from precision to uncertainty divided by 2, right? If I asked you to go from uncertainty to precision, this times 2, did I ever talk about that? Yeah, that's probably a good one on your study sheet, because sometimes the problem says, hey, this is the uncertainty, what's the precision? They do go backwards sometimes. Define tolerance using your own words. Why am I doing that again? Oops. You could say the range, another way of saying it, the range or difference between the max and the min. And so if you want to have a visual, right, this is the max, this is the min, and tolerance is the difference between, like literally how wide that gap is between the maximum and the minimum. Okay? By the way, this is another good study sheet entry. If you have the max and the tolerance, you subtract the tolerance to get to the min. If you have the min and the tolerance, you could add the tolerance to get to the max, right? There's also a bit of a loop going on there. Okay? Anything in between here is acceptable. Anything outside of it is not, either on the low and on the high. Okay? In each case, state the nominal, maximum, minimum, all of that jazz. Here, the nominal is the one that I want you to, when there's a big number up front, doesn't matter if it's a big number. If there's a number up front, that's your nominal. So for this one, my nominal is that, inches, right? And so the max, you just add this. I'm going to need your help. Let me see here. I don't have the key in front of me. Is it this? 40186. Yeah, okay. So we're good, right? Okay. Minimum, you just subtract and it's 0, so it's just going to be 0.0180. I would not drop any zeros if I were you, just to make sure, because we're in precision measurement. They don't want you to round. So let's just leave it like that. Here, the minimum is subtracting these two, right? And what do max, sorry, let's do our max first. We go this plus that, that'd be 0, 4, 8, right? Inches. Minimum we subtract, so we have 8 at the end for sure. 18, right? 0, 18. Okay. Mental math, whew. Hurts. So I would just say half a mark for each correct entry, right? So 1.5, you get half a mark for each correct entry here as well. One thing that I've noticed is your ruler reading skills need some honing, okay? Precision on an imperial ruler. I'm gonna go over that before we go home today, just to make sure you get that right. That's what I kind of saw that was lacking. Given the tolerance of a pipe, okay, so we've got the measurement. This is not uncertainty. We're in the tolerance kind of concept here. State the tolerance in 3 other forms. I like to do my inventory real quick. What is the inventory, right? Max, min, tolerance, nominal. Okay, I do that on the side. So this is my nominal. My tolerance is it that? I wouldn't go so fast, right? Let's go get our max. Our max is 355.75. Our min is 355.25. The tolerance is the difference between the two. That's why I ask you to do this on the side, not just grab numbers. So the tolerance is 0.50 centimeters, okay? So now I know my max and min. I can state it. It's 355.75 centimeters, 355.25 centimeters. Okay, make sure you have units. The max is 355.75 centimeters plus 0 centimeters minus 0.50 centimeters. Minimum, 355.25 centimeters minus 0 centimeters plus 0.50 centimeters. Okay. There we go. Jenny's sewing together 2 pieces of fabric as stated. What's the total combined max and min? What's going on here? Combined should tell you something, right? We're going to figure out the precision and uncertainty of both. Right? Precision and uncertainty of both. They happen to have the same uncertainty. So it's up to you how you want to do it. I'm going to go like this. I'm going to state both of those measurements plus or minus their uncertainties. Okay? You're going to get, how should I say this? If you come up with the uncertainty, you're going to get a mark for coming up with these uncertainties to a certain degree. Then you're going to get another mark for adding. So if you add, you get 4, that's 14, that's 11, right? 114.4 plus or minus 0.1 centimeters. You're going to get a mark for coming up with this at some point. And don't fret just yet. If you get the 2 final answers and you showed me work, you're going to get 3 out of 3. So, but out of this, you're going to get your max and your min. I get the max by adding, so it's 114.5 centimeters. And you subtract it, so it's 114.3 centimeters is my min. Okay? So I'm going to give you half and half for that. So 1, 2, 3. So if you have these stated clearly which one is which, don't just have 2 numbers show up like that, because we need to know which one is max and which one is min. Which one are you saying is our max? And so, because we're sewing together, we're adding up the actual measurements, and we always add the uncertainties. There's no question about that, okay? So this page is 3, 6, 9, 10, 11. It's a little unfair, like the explaining ones, but that's okay for now. It's just practice. Backside. Explain which beaker is more precise. Be specific to earn full marks. You figure out the precision, right? So this is 20 here, this is 40. Remember, precision is from marking to marking, not number to number. Some students, oh, it's 20. No, it's not. Precision is by the markings. So this one is 10. You can go 40 minus 20 if you want, divided by 2 gaps, right? So that's 20 divided by 2, that's 10. Precision is 10 mLs for this beaker. And this beaker over here, from marking to marking, it's 50. I don't think we need our formula for that one. Okay? So you show me your work. That would be a mark figuring out the precision for both. Beaker A is more precise as it has the smallest increment. Or you can say it has the smallest precision. This is what you cannot say. You ready for this one? You cannot say, oh, it's this one is more precise because the markings are closer together. That's not going to fly. Sometimes they actually make you believe one is more precise than other, but when you do the math, you figure out, oh, it's actually this one, right? So you got to figure out the precision to be able to answer this correctly. So 2 marks if you've shown work and if you're determining which one is more precise. Given the tolerance, state the nominal value, it's 25, okay? There's no need to add or do anything like that. What about this one, folks? This is an aside. If I gave you 50 and 40 mLs, what's the nominal when the tolerance is stated like that? Yes? The top number? No. No, it's not. Add them and divided by 2. Okay, you got to find the midpoint. Okay, guys, I don't know, the province does that to us. They don't figure out which term they're going to use. They say midpoint, halfway, the halfway point, halfway in between the max and the min. They'll say something like that. Doesn't matter. You add and divide by 2. That's what you're doing. You're finding the middle. Okay, so this will be 50 plus 40 divided by 2. Make sure you do the top first. So that would be 45 ml is the nominal. Okay, that's an aside. That's the only one where you have to do math to figure out your nominal. Okay, unless the question says, so Will, I'll redeem you here, okay? If the question says that the nominal is also the max, please don't do this. Right, don't calculate, then that is your nominal, obviously, right? But if it's just stated like that and they tell you that it's the midpoint, then we're assuming that this is the case. Okay, I'm a little bit of a wordplay here. 2x4 is just a piece of lumber, right? We call it 2x4 in construction to do framing and whatnot. So this is not supposed to go into your work, okay? I don't think the exam would ever do that, but there it is, recorded at 2.35. The target is 2.43. Explain why the measurement might be off. What is the problem here? Out of uncertainty, tolerance, precision, accuracy, which one? Okay. You're kind of not completely wrong, but the province would want to hear something else. So uncertainty is out. What is left? When there's a target and you're off, we're talking accuracy. Oh, were you going to say that, Emil? Yes, yes. So that affects your accuracy. The measuring tool is effective. So, but we were talking accuracy, okay? But that is a good explanation why that might be off. I just want you to know that if it was a multiple choice, accuracy is the one you would want to circle here. Accuracy is affected. You don't have to write all of this, okay? I'm just reviewing. Is affected by the unit, the scale, the device, and use, okay? Any of those four you mess around with, it's gonna affect it. So technically, Will, the scale is kind of affected, but it has to do with precision and uncertainty. If you're dealing with, like, if you're using a kilometer to measure this table, your uncertainty will be way off, and so the measurement will be off. But okay, fair enough. I will focus on device and use, okay? So you can say the measuring tape may have had some missing marks, missing markings, okay? Maybe that's what happened. Maybe he didn't hold it straight flat against the board. The tape was not held flat against the board. I'm just thinking, like, I worked a little bit in construction, but what happens to lumber when you let it just lie in the sun all day? What's going to happen to that lumber? It's going to, like, warp, right? It's going to, like, bend and stuff. So maybe that could also be mentioned here. Okay. The board was left out in the sun and warped. Okay. This caused an inaccurate reading, okay? Yikes. Okay, something like that. We're just gonna leave it there.